Welcome back to the Comptia Network Plus course, Mobile Hotspots. Let's say you're in a location that doesn't have an access point installed, or they want to charge you for access and you want to connect your laptop, tablet or even play a game. What can you do? You've got a couple of options, but they all include a cellular network as an infrastructure. Not being an ad for AT&T, but figure 1215 shows a mobile hotspot device that connects your laptop, tablet, media devices or even a gaming device to the internet at decent speeds. Pretty much all cellular vendors sell a version of these hotspots now. So you can see here figure 12.5, this is a mobile hotspot. But let's say you don't want to carry yet another device around with you, or that you just want to use your phone instead. Figure 12.16 shows how I turned my iPhone into an access point for my laptop. First I went to settings, then I chose personal hotspot. If that option doesn't show up for you, just give a quick shout to your carrier to have it enabled. Signal degradation. Something that's really important to consider when installing a wireless network is signal degradation. Because the 802.11 wireless protocols use radio frequencies, the signal strength varies according to many factors. The weaker the signal, the less reliable the network connection will be, and so less usable as well. Think dropped calls. There are several key factors that affect signal strength. Distance. This one is definitely an obvious side. The farther away from the wireless access point you get, the weaker the signal you get. Most access points have a very limited maximum range that equals less than 100 meters for most systems. You can extend this range to some degree using amplifiers or repeaters, or even by using different antennas. Walls and other barriers are also easy to imagine in the fact that more walls and any other office barriers a wireless signal has to pass through. The more attended, reduced the signal becomes. Also, the thicker the wall, the more it interrupts the signal. So an indoor office area with lots of walls, the range of your wireless network could be as low as 25 feet. You really have to be careful where you place your access points. Protocols used, this one isn't so apparent, but it's certainly a factor that affects, can even determine the range of a wireless LAN. The various wireless 802.11 protocols have different maximum ranges, as discussed earlier and illustrated in figure 12.7. The maximum effective range varies quite a bit depending on the 802.11 protocol used. For example, if you have a client running the 802.11g protocol but it connects to an access point running only the 802.11b protocol, you'll only get a throughput of 11 megabits per second to the client. Interference. The final factor that affects wireless performance is outside interference, because 802.11 wireless protocols operate in the 900 MHz, 2.4 GHz and 5 GHz range. Interference can come from many sources. These include wireless devices like Bluetooth, cordless telephones, cell phones, other wireless LANs, and any other device that transmits a radio frequency RF near the frequency bands that 802.11 protocols use. Even microwave ovens, a huge adversary of 802.11.b and 802.11g, can be serious culprits. Other network infrastructure implementations. We've discussed the wireless LANs, WLANs, created by installing access points, but there are other technologies like personal area networks which create infrastructures too. By far the best known is the even popular Bluetooth. but there are other wireless technologies we can use as well, and we'll take some time to explore these soon. For now, it's back to Bluetooth, which happens to be a fantastic history behind it. The technology was actually named after the fabled 10th century Viking Harald Blanton Gormason, who was faced with the challenge of dealing with many disparate tribes. He needed to communicate with them all, and they needed to get along with each other. Blackland, who is said got his unique nickname due to sporting an unfortunately prominent Bluetooth, was having a really tough time getting this to happen. However, the Viking was a famously great diplomat, possessing a wonderful way with words. He is effectively a non-violently united ancient Norway and Denmark into a single territory via his powerful communication skills. Incidentally, Blackland just happens to translate into Bluetooth in English. Fast forward in modern times, and a Scandinavian company called Ericsson, a highly gifted technological innovator, Jim Kardach, as one of the founders of Bluetooth. Kardach's challenge was a decent modern day analogy to the ancient Vikings. He was faced with making disparate phones, computers and other devices communicate and cooperate effectively. To answer the challenge, Kardach came up with the element technologically wireless solution to make all these disparate devices communicate and play well with each other. To come up with an equally cool name for the brilliant innovation, he did some research, discovered the legend of the ancient Viking, and code-named the new technology Bluetooth. It stuck. Now all that was left was to create a super slick logo for it. Today, Bluetooth's icon is actually the legendary king's initials in ancient Viking runes merged together. Bluetooth operates in the 2.4 GHz range, so while it can cause some interference with 802.11bg, it's really low power. Plus, the electronics in our wireless LANs are much better today than they were in the past. Sorry now. Lost where I was. Just bear with me. Okay, so it really isn't much of an issue anymore. So at last, modern wireless communication works nicely for us today, making our technological lives much easier. To delve a little deeper into wireless technologies, the idea of PANs is to allow personal items such as keyboards, mice and phones to communicate to our PC, laptop, display, TV wirelessly instead of having to use any wires at all over short distances up to 30 feet. Of course, this idea of the wireless office hasn't quite come to fruition completely yet, but you have to admit that Bluetooth really has helped us to tremendously in our offices and especially in our cars. Here are two other network infrastructure implementations in the PAN area: infrared and near field communication. Like Bluetooth, infrared has some history behind it, but the technology's idea only goes back to about 1800, because that's when it was first said that the energy from the sun radiates to the earth in infrared. We can use infrared to communicate short range with our devices like Bluetooth enabled ones, but it isn't really as popular as Bluetooth to use within network infrastructures. Unlike Wi-Fi and Bluetooth, the infrared wireless signals cannot penetrate walls and only work line of sight. Last, the rates are super slow and most transfers are only up to 115 kilobytes per second, up to 4 megabytes per second on a really good day. The last implementation I want to cover is called Near Field Communication, NFC. For NFC to work, The actual antenna must be smaller than the wavelength on both the transmitter and receiver. For instance, if you look at a 2.4 gigahertz or 5 gigahertz antenna, they are the exact length of one wavelength for that specific frequency. With NFC, the antenna is about 1/4 the size of the wavelength, which means that the antenna can create either an electric field or a magnetic field, but not an electromagnetic field. NFC can be used for both wireless communication between devices like smartphones and or tablets, but you need to be near the device transmitting the RF to pick up the signal really close. A solid example would be swiping your phone over a QR code. Technologies that facilitate the Internet of Things. The Internet of Things is the newest buzzword in IT, and it means the introduction of all sorts of devices to the network and internet that were not formerly there. Refrigerators, alarm systems, building services, elevators and power systems are now equipped with networked sensors, allowing us to monitor and control these systems from the internet. These systems depend on several technologies to facilitate their operations. They can include the services in the following sections. Z-Wave. Z-Wave is a wireless protocol used for home automation. It uses a mesh network using low energy radio waves to communicate from appliance to appliance. Residential appliances and other devices such as lighting control, security systems, thermostats, windows, locks, swimming pools and garage doors open can use this system. And Plus is another wireless protocol for monitoring sensor data such as a person's heart rate or a bicycle tires pressure, as well as the control of systems like indoor lighting or a television set. And Plus is designed and maintained by the And Plus Alliance, which is owned by Garmin. Bluetooth. Some systems use Bluetooth. NFC. Some systems use near field communications. IR. Some systems use infrared. RFID. While RFID may most known for asset tracking, it can be used in the Internet of Things IoT. Objects are given an RFID tag so that object is uniquely identifiable. Also, an RFID tag allows the object to wirelessly communicate certain types of information. Truly smart objects will be embedded with both an RFID tag and a sensor to measure data. The sensor may capture fluctuations in the surrounding temperature, changes in quantity and other types of information. 802. Finally, 802.11 can be used for this communication. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.